Hi everyone, welcome back to Chem Help ASAP. In this video, we are going to define acids and bases, and specifically we're going to use two different definitions. We're going to use the Arrhenius definition of acids and bases, and then we are going to use the Bronsted Lowry definition of acids and bases. Let's get started. Let's start with our simplest definition of an acid and a base. We'll start with our Arrhenius definition. Now, in the Arrhenius definition, an acid is a molecule that is going to produce a proton in aqueous solution, and a base is a molecule that is going to produce a hydroxide ion in aqueous solution. So let's see an example of this. Let's take hydrochloric acid for our acid. When we put it in water, we get a proton, or an H plus cation, and a chloride anion. It is an acid in the Arrhenius definition because it has produced a proton. Let's take a look at a base, sodium hydroxide. When we put this in water, we get a sodium cation, and we get hydroxide as an anion. Because we get hydroxide, it is a base according to the Arrhenius definition. Our Arrhenius definition works very well for many acids and bases. However, there are some species where the Arrhenius definition just does not fit, and one of these species is ammonia. Ammonia is a known base, however, it does not produce hydroxide ions. So two scientists, Bronsted and Lowry, came up with a broader definition for acids and bases. So using the Bronsted-Lowry definition, an acid is going to donate a proton in aqueous solution, and a base is going to accept a proton in aqueous solution. Let's look at some examples. Our hydrochloric acid in aqueous solution still is an acid under our Bronsted-Lowry definition. It's still donating a proton. For our base, let's take a look at ammonia because it does not fit our Arrhenius definition. However, it will fit our Bronsted-Lowry definition. So for Bronsted-Lowry base, ammonia must accept a proton, and it does this by accepting a proton from water. It forms the ammonium cation, and what's left is hydroxide from this OH left in water. So our ammonia molecule has accepted a proton from water to become ammonium. Before we leave our definitions, there is just a little bit of vocabulary that I want to go over. Many acids can donate more than one proton, and we have names for those. So when an acid can donate one proton, we call it a monoprotic acid. If it can donate two, it's a diprotic, or three, it is a triprotic. Now obviously there are acids out there that can donate more than 3 protons, but for our discussion, 3 protons is generally going to be our max.